Nice to meet you. This is the Hobby IT channel. Thank you for watching today. In this channel, it is a video that challenges making things with IT. Programs and circuit diagrams are available on the website below, so please make use of them. Let's have fun together. I would like to do electronic work that acquires images with an IoT camera and saves them in Google Drive. The series was supposed to be completed in 4 videos. The first was an overview, the second was the Google Cloud setup, and the third was the hardware. This time it will be the 4th one, and it will be software. The content of the software is a program that connects to Wi-Fi at startup, acquires images with the camera, and saves images to Google Drive using the Google Cloud API. As for the development environment, we will use Arduino to create programs. The Arduino IDE for this development environment software can be downloaded from the Arduino official website. All you have to do is connect the Arduino IDE to your computer with a micro USB cable and you're ready to go. Check the Arduino IDE settings for the ESP32 used this time. First, make sure that the board is ESP32 dev module. When using ESP32, the board setting must be set to this setting. Port is the port the ESP32 is connected to. If you cannot select it, there is a problem with the physical connection, or the OS is not recognizing it properly, so please check. Also, other settings are like this, so please refer to them. Next, we will check the basic specifications of Arduino when creating a program. Arduino has 2 functions whose roles are predetermined. There are 2 functions, the setup function and the loop function, and it is necessary to understand the contents. However, since the contents are very simple, I think that you will be able to memorize them immediately. First, the setup function, which is the first function executed at startup. This function is executed only once at startup. Therefore, basic settings at startup such as port settings and Wi-Fi connection, as well as contents that need to be performed only once at startup, are executed here. Next is the loop function, which will be executed repeatedly while the device is running after the setup function is executed. Therefore, do here what you want to repeat while the device is booting. In addition to these 2 functions, it is also possible to create individual functions. A group of processes can be created as a function with an arbitrary name. Individually created functions are executed using either the setup function or the loop function. First of all, I think that this understanding is enough, so let's take a look at the contents of the main program. Here is the program created with Arduino IDE. There is no problem with the file name, so it will be copied and pasted from the Hobby IT site into a newly created file. I will check this program. Loading the library first. Use Wi-Fi client secure and ESP camera. This is a library that can be used as standard in ESP32, so if you describe it here like this, you can use it without adding a separate library. Next, I'm setting up a global function. This very first part has settings to change. You can use it by changing only this part. Change the settings related to Google Cloud and your home Wi-Fi settings. If you do not know how to obtain the settings related to Google Cloud, please refer to the URL described in the explanation column. The contents that are determined when using the Google Cloud API are defined here. Next, we set the port for the LED. Since I wired to use IO4 in hardware, I set port 4. Next, set the camera port. This is also set to match the content wired in the hardware. Next, set the variables to be used globally. Since it is set globally, it can be used in any function. This is the basic setting, and the setup function starts from here, and we will describe the operation. First, enable the serial port. This makes it possible to display the log serially, and it is used for checking the status such as where the program is executing and for debugging. Next, let's start the camera. First, define the port settings to initialize the camera to use. Since the port number has already been defined according to the wired content, that value is set. I scrolled down. Perform initial setting processing and init of the camera. After execution, check for errors at startup. Next, set the status display LED. This port outputs power and displays an LED, so set it as output. Next, perform Wi-Fi connection processing. Set the SSID and password of the Wi-Fi to be connected, and connect. Check the connection status every 1 second and repeat until the connection is completed. Since the loop is exited only in the connected state, the next operation will not proceed unless the connection is established. Then do NTP processing. NTP is a function that sets the correct time. Since there is a server that notifies the correct time on the internet, specify it and set the time on ESP32. It may not be necessary, but it is set because the time is used for the file name this time. This NTP setting is not necessary if you do not use the time in the file name, such as saving with the same name each time. Next, it is a setting whether to check the server certificate of HTTPS communication. I am skipping this time. Since it is HTTPS for accessing the Google Cloud, Google will not take over the server illegally, and this time it is only an operation check, so security does not need to be strong, so I skipped it. If you want to make sure that the access URL and server are correct, you can set the root certificate and check the server certificate as usual. Next, we will execute the function getCameraJPEG to acquire the camera image created individually. Let's take a look at what this function does. Here is the function, getCameraJPEG. It's very simple. If the camera suddenly acquires the image, the color may become a little bluish, so after acquiring the image several times, the image to be saved is acquired. When the image acquisition process is completed, after confirming that there are no errors, and processing is performed and the process is complete. The image acquisition process is functionized in the library, so you can easily acquire images with the camera. Therefore, the image acquisition process ends here. I would like to go back to the original setup function. Next, we will use the Google Cloud API to save the image to Google Drive, but in order to do so, we need to obtain an access token. We will get the access token from the refresh token etc. The access token to be obtained has an expiration date of about 1 hour, so it is updated from the refresh token every time the data is saved. This time, we will check the getAccessToken function that we created individually. First, connect to Google servers here. If the connection can be confirmed, the information of the body part is created first and preparations are made. After that, the information in the header part is sent. After the header part, the created body part is sent. Let's check what packets are being sent. Here is the packet sent by the previous program. The part in double brackets will be rewritten with the acquired value and sent. Send such data to Google server to get access token. Send via HTTPS post and get an access token using the client ID, client secret, and refresh token. Now let's get back to the program. After sending, we are waiting for signal reception from Google server in this while. If there is an access token in the received signal, we get its value here. When reception is completed, HTTPS communication is terminated. After that, if the acquisition fails, the ESP32 body is restarted after 3 seconds and it tries again from the beginning. This completes the processing of this function. Return to the setup function again. Then save the image to Google Drive. I am handling that role in this post Google Drive by API function. Again, let's take a look at the contents of this function that we created separately. As with the access token acquisition function, access the Google server via HTTPS communication and send the image data. First, connect to Google servers here. When the connection is completed, the processing in it will be performed. I am creating the file name first. Get the time and create a file name. The body part to be sent next is created here. In addition, the information of the header part is created here. I am submitting the information I have created here. Let's take a closer look at what the packet we're sending looks like. Here is the packet I am sending to save the JPEG data. The boundary, which is delimiter information, is set first to distinguish between header information and JPEG data information. This boundary character string is decided here, so it can be any character string you like, but it must be a character string that does not exist in the data content to be sent. Because it is necessary to clarify the delimiter position. Google servers determine the type of data sent by this boundary. Also, the access token obtained earlier is sent as authentication information. If this value is not normal, data transmission will not be accepted. Data information to be sent and JPEG data are sent in sequence. Since the JPEG data has a large capacity, the data is passed in units of 1000 bytes. When all the data has been sent, the boundary is sent as a signal that the data has been completed, and the process ends. I'm worried about memory consumption if I pass a large amount of data to the OS at once, so I'm programming like this. Packets that are actually sent are also divided into multiple pieces and sent so that they do not exceed the maximum packet size of 1500 bytes for Ethernet. Then wait for a response from the Google server here. When I receive the response, I display it on the serial monitor. If the acquisition is successful, the following information will be displayed on the serial monitor. Error information will be displayed even if it fails, so take action according to the error content. Finally, terminate HTTPS and this function is done. We return to the setup function, which is the end of the process. The setup function that is executed when the Arduino starts up ends. After this, it moves to processing the loop function, but there is no processing, because this time it just grabs the image on startup and saves it to Google Drive. Although it may not be necessary to describe it in particular, only delay, which is a sleep process, is executed just in case so that the CPU is not overloaded. This concludes the description of the program. By writing this program to ESP32 and starting it, you can acquire images with the camera and save them in Google Drive, as you saw in the overview video. Also, check your Google Drive folder. We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.